Welcome to Plutus STEM, and today we are covering a topic from your organic chemistry, that is hydration of alkenes to form alcohols. Now this mechanism is very important, especially from the point of view regarding the boards exams, because in boards exam it has been seen a consistent pattern that hydration of alkene has been asked a multiple of times in every single year. At least it is asked one time. So today we are going to cover it and try to figure out how alkenes are hydrated to form your alcohols. So first thing that we need to keep in mind that hydration of alkene often goes by a name of that is called as your acid catalyzed reaction. Acid catalyzed reaction. And why we call it so, we can discuss is as, let's see, if you have your alkenes. Alkene is what? Alkene is a hydrocarbon. It is a hydrocarbon, and like any other hydrocarbon, it is non-polar in nature. Moreover, it has an oil-like feature. If now it's more easier to understand. So if you are directly trying to react alkene with water, simply they do not mix. Since they do not mix, there is no reaction between the two. So the direct reaction of alkene and water is not possible. So we need to add some catalyst that can favor this particular reaction. So if you have any kind of alkene and you take water with some amount of acid or diluted acid like H2SO4, H3PO4, etc., and they can cause the formation of alcohol of the alkenes. And another important thing, hydration of alkene follows Markovnikov addition rule. Markovnikov's addition rule. That means the OH minus will be added to that carbon of the double bond which has lesser number of hydrogen. Now let's move forward with mechanism. We have covered all the basic parts that were necessary. So first, it is a three-step mechanism. So the first part of the mechanism follows the protonation of alkene. So first what happens is, when you have water molecule, this water molecule first interacts with the protons which are generated by the acids. Now, on which the oxygen has lone pair. So that means the oxygen can act as a nucleophilic center, while H plus ion have positive charge, so it can act as a electrophilic center. So this water molecule attack this H plus, forming hydronium ion. Now, in the second part, now remember, this is just a one single step in alkene. Now, the hydronium ion is very unstable. It's very unstable. So here, the H plus being generated here. So for oxygen to stabilize it, it abstracts the electrons in the oxygen hydrogen bond, now creating a new highly reactive electrophilic center which was initially not possible to react with. So here, any carbon will take up the electrons and attack the H plus. Hence, this process will lead to carbon H plus. Now, since the electrons of this bond were taken by another carbon, this leaves behind a carbocation. And this particular step is called as your protonation of alkene, or we simply call it protonated alkene. Now, after this part, this carbocation, that this one is highly reactive species. So now, this will be our new electrophilic center. That's our new electrophilic center. So for the second set, we will go for the nucleophilic attack of water. So like any other electrophilic species, we have a carbocation right here, and we have our water molecule, which can again act as a nucleophilic center. So what will happen? The oxygen will take up its lone pair, attack the carbon, the hydrogen will remain like that, forming. And remember, this is a mechanism, so we need to make double-sided arrows. Here, H2O forms, and here, our carbocation gets stabilized, forming a OH molecule, which has an extra hydrogen before it can get completely formed as alcohol. So simply, if I remove this proton, which is H plus, to stabilize this oxygen, what I get? I will get my alcohol. So in this entire alcohol, the extra portion that I am having is nothing but this particular bond in the molecule. And this, because of this particular reason, this particular species is called as your protonated form of alcohol, called as your protonated alcohol. This protonated alcohol needs to get stabilized. So the only option is I can either withdraw electrons from the carbon oxygen bond or from the hydrogen oxygen bond. Now since the electronegative difference between the oxygen and hydrogen is much larger compared to the carbon oxygen bond, it is much easier for the oxygen to break the electrons, to take the electrons from the hydrogen oxygen bond rather than the carbon and oxygen bond. So the next step that we'll have, that is the deprotonation, removing that extra proton which you utilize in the very start to form your hydronium ion. So in the next step, we have our molecule having an extra proton with positive charge. Here it will lead to deprotonation by abstracting the electrons from the oxygen hydrogen bond, giving us alcohol, which is our final product right here. So this is the mechanism how alkenes are converted to alcohol. So you have seen the mechanism, we understood the basic intricacies, which portion will attack which side, which particular bonds need to be broken, why carbon oxygen bonds are not being broken, why oxygen hydrogen bonds are being broken, which intermediates are being formed in the reaction, and one of the most important things, that now we have a complete idea why acid forms an essential part of this mechanism and why this reaction specifically called as acid catalyzed reaction. The important reason, it is the acid that activates the water molecule for the reaction, because in a normal scenario the water and alkene do not interact, hence the reaction between them is not possible. So I hope now all your doubts regarding the hydration of alkenes has now been completed. In case of any doubts, you can add it to the comment section and we'll get back to you. In case you have any doubts, you want some specific topics to be dealt with, you can add it to the comment section and we'll get back to you. And that's all for now. Thank you for joining us today.